All right, as software developers, we often have to deal with different kinds of environments like Windows, Linux, Mac OS, and we want to run LLMs on those different environments. But the question that often comes up is, well, what's faster? Is it Linux or is it Windows? Is Windows going to hinder your performance for LLMs? So I've got here LM Studio. We're going to pick a model real quick here. Let's do this one, Gemma 3 4B. I got a bunch of them I'm going to run today, but we're going to start with that one just to get a baseline. And I'm doing 34 layers out of 34 for GPU offload. We want to run everything on the GPU today. And I'm going to check that through my task manager here in Windows. I'm starting out with Windows, but we're going to do Linux too, don't worry. And taking a look at the GPU here, I've got the NVIDIA GeForce RTX 5080, 16 gigabytes of memory, VRAM, and 6.7 of dedicated memory is being used by this model. It's loaded up. Let's just warm it up by saying hello. Now, I know some of you are going to say, hi, that's not a very good prompt, is it? It's not realistic. No, it's not realistic. It's only one token, but it gives us a good baseline. It's going to be a relative comparison between the different machines. I'm also going to send other prompts, of course, but here is a good start with one token. And for those of you that are not familiar with how LLMs work, the more tokens you send to it, the slightly slower it generally gets, So this is going to be the fastest possible output, and we're getting 102 tokens per second here with this model. Now, as for hardware goes, yeah, I have a couple of different pieces that I've been testing here. This is the 5090. This is the RTX Pro 6000. This is brand new that I just got. I haven't had a chance to test it out yet. Stay tuned for those videos for sure. But the point is not to compare the hardware. In fact, if you do want to see those videos, let me know in the comments down below comparing these cards against each other. I bought all the different NVIDIA varieties, and no, they did not send them to me. I kind of wish they did, but no. I was out there hunting for these things. This one was especially hard to get, but I'm getting off topic here. And another thing about hardware, notice I don't have a Mac here today. I have plenty of videos comparing Macs with these things, so check that out if you're interested in that specifically. But today, I want to keep the hardware exactly the same, which is the point of this exercise. I'm doing the exact same machine, which I got right over here. This is my AI machine that I built a month or so ago. I swapped out the 4090 to the 5090, and now I'm on the 5080 in there. So we're gonna keep it at the 5080. The next thing I wanna do is, well, I want to test this out in WSL because that's a valid environment where people do their work. It's Linux inside Windows. And if you don't know what that is, or if you've never used it, basically it's like a full Linux kernel running inside Windows. But it's not a virtual machine. It lives directly inside the kernel. I believe somebody will correct me in the comments, I'm sure. But the point is, the performance degradation is supposed to be very, very small. So we're not even supposed to notice any performance degradation. Well, let's see. I installed LM Studio here as well. And, well, let me quit this one. Just remember, 102 tokens per second for Gemma 3 4B IT. And I want you to take a guess right now. What's gonna happen when I run the Linux version of that in WSL? Notice I quit the other one. And yes, I have my GUI enabled here. So there's an extra little overhead going on over there, and there it is. Now here you see that we're still getting that GPU offload of 34 layers out of 34, even though this is running inside WSL. It means it's communicating properly with our GPU. In fact, when you install WSL, the latest version supports GPU offload, so we're good to go with that. I'm gonna load that up, and we can prove this by just going to Task Manager in Windows now, and you'll see the model is now taking up some GPU memory. We're good to go. Let's say hi here. Boom. And there it is. What? 108 tokens per second. Of course, that's within the margin of error, but that's pretty good. Now we're down to 82 because I said hi again. And the second iteration of that is going to take that entire conversation as context. So it's going to be a little slower. That's to be expected. Let's start a new conversation and say hi. 118 tokens. We're just getting faster and faster here. One more time. 103. Okay, so you see the range there. We're just between 100 and 118, somewhere around there. I want to go back to Windows now and do it again. But if you're in WSL and you want to use LM Studio or LM Studio CLI, the CLI is pretty cool, by the way. You can query everything and load up models through the terminal programmatically. In fact, I recently did a members video showing how to do all that. As an aside, thank you to the members of the channel for supporting the channel. Members get extra videos and things like that and live streams. So if you want to join, there's a join button right down below. But also if you subscribe, that's just free and you get all these videos. All right, let's go back and close this one out. And I just want to go back and redo LM Studio one more time in Windows. There's our model 34 out of 34. And I'm going to create a new chat and say hi real quick here. Boom. 115. So as you can see, between WSL and Windows, not much of a difference there. So you can be working in the Linux environment in WSL, but I know what you're thinking right now. I mean, I know what you're thinking. You're saying, Alex, this is not real Linux. Well, it kind of is. It mostly is. But the thing is, it's not living on the hardware, right? It's not directly on the metal. So let's do that. Let's have Linux be on the metal. Next week, I'll be at Google I/O shoulder to shoulder with thousands of developers on the same sketchy public Wi-Fi. My source code and my NAS login are staying private, so Surfshark comes with me. One tap and every packet, git push, docker pull, slack ping shoots through an AES 256 encrypted tunnel. CleanWeb is their ad blocking service, and it quietly nukes the trackers that slow pages down. Surfshark keeps no logs. Deloitte literally checked this, and the servers run on RAM only, so a reboot wipes everything. My favorite perk? Unlimited devices. I run it here on my MacBook, on the mini PC media servers back at the office, and on my phone so I can upload my B-roll from the hotel without ISP throttling. Go to surfshark.com/AlexZiskind or use code AlexZiskind at checkout to get 4 extra months of Surfshark VPN. And of course, a 30-day money-back guarantee, so it's risk-free to try. Now I'm gonna shut down Windows and get it to Ubuntu. And by the way, it is pronounced Ubuntu. That's the right way. Not Ubuntu, not Ubuntu. It's Ubuntu. All right. I want to show you that I have all these models here, and I wrote a little program that automatically, using LM Studio CLI, loads all these up one at a time, does some prompts against them, not just a short little prompt, but a little bit longer. And I'm going to run that, and I have not seen the results yet. So I'm really curious to see what the result will be on all these, because different models are going to act slightly differently. This was Gemma 3. We saw that it's pretty much the same, but the architecture of the model, like Quen, Llama, or Gemma, and others will behave slightly differently. And let's go ahead and restart this machine. Did it freeze? Come on. What happened here? Restart. Boom. I missed the old dedicated restart buttons, or reset they used to be called. Do you remember those? Come on. I was just in you, Ubuntu. These things happen. That's how things go. When you expect something to work, it doesn't. Good thing this is not live. Reboot. We're getting closer though. I feel like this reboot is gonna be the one.
One eternity later.
All right, I just downloaded the model again, and here I am in Ubuntu on the metal, and I have LM Studio installed. Let's make it a little bit larger. Whoa, 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 whoa. Right over here, Gemma 3, 4B, boom. And notice this is detecting our NVIDIA GPU. How do we monitor that? Well, there is no task manager here per se, but there's NVIDIA SMI, which shows me that we are on the right driver. It's the latest driver. But there's another little tool here called NVTop that we can run. Hopefully, we'll be able to see the activity. There's a memory chart right here, and right now it's showing us 1.28 out of 16 gigs of VRAM is being used. And there's the GPU activity, which is 0 right now. So let's load up this model, create a new chat, load up model, Gemma 3, boom, and load. And you'll see that there it is. There's our memory going up. We're about 6.7 gigs. That was actually pretty fast. It seemed faster than on Windows. Let's say hi to our little model here. Boom. What? Holy smokes. I take it back. All you people that said things about Linux being faster, you might have been right. Let's do that again. Hi. 170 tokens per second. Oh my goodness. This is a ridiculous speed up over Windows. 173 for the same model. I'm just blown away. This is crazy. All you people that are working in Windows, I know that you have to. I know that people have to. And people that are Linux people, don't yell at Windows people because they have to, okay? But wow, this is crazy. Now let's take a look at the chart that actually takes all the models that I have installed in LM Studio and uses LM Studio CLI to iterate over each of the models, pull them in, load them up, run a prompt against it, note down the tokens per second, and tell me what that is. So let's see what that is. For WSL, I have, here's DeepSeek R1 Distill Quen 7B, and we're at 122 tokens per second. Let's find that same one on Windows. Here it is, 143. So quite a bit more. But what's that on Ubuntu? Here it is, 135. So in this case, for some reason, it's a little bit less in Ubuntu. There was a significant jump in the Gemma 3.4b, but for DeepSeek R1, slower. Again, it's a little bit within the margin of error there, but for this model, it doesn't seem to matter that much. Let's take a look at a model that's a little bit more useful. This Gemma 312 billion. In Ubuntu, we're getting 83 tokens per second. Windows, 71, slower in Windows, and 66 in WSL. So a pretty consistent drop there from Ubuntu being the highest to WSL being the lowest. Quen 2 Coder 14B, 66 in WSL, 70 in Windows, and there it is, 74.9, almost 75 in Ubuntu. Ubuntu seems to have a slight edge. Not as huge a jump as we saw initially, but still. Let's take a look at Gemma 3.1 billion. Ubuntu, 288 tokens per second. Windows, 307. Faster. Holy cow. Notice Llama 3.21 billion went up to 367 tokens per second on Windows. And Gemma 3.1 billion, 193 in WSL. Wow. That's still fast, but the difference between WSL and Windows and Ubuntu here is staggering for the smaller models. Notice that on Ubuntu, the larger models just completely failed. On Windows, those larger models, the 32 billion models, those are models that are really large and they barely fit, if not fit at all, inside the VRAM of that video card, which is a 16 gigabyte video card. They ran really, really slowly. What that means is that LM Studio offloaded some of that to the CPU, making it extremely slow. We don't want to do that in real life, but it happened here. And QWQ 32 billion parameter model, this Q4 quant, try saying that fast 10 times. That's not going to happen. That model is 18.49 gigabytes on disk, so it's going to be even larger when you load it up. I can't believe it ran, but it did. The Windows version of LM Studio allowed it to. Let's see what happened in WSL for those. Yeah, look at that. It ran in WSL too, giving us an even lower score, 1.7 tokens per second. Unacceptable, but it ran, which is pretty incredible. So luckily, the comparison here is a standalone comparison because everything is kind of relative here. Now, if you want to see how this card does, definitely subscribe and stay tuned for that. I'm also working on another video with the AMD Ryzen AI Max Plus 395. A couple of those, including this new little machine right here. The video might be done already, and if it is, it's going to be up here. And this one is another one you might want to watch. So thanks for watching, and I'll see you in the next video.